All right, we're back. We're on page 8, note 16. We're now talking about vector-valued functions. We were talking about parametric. For the purposes of Calc BC, parametrics and vectors might as well be the same exact topic. I mean, there's no real difference in what you do. The only additional thing is you'll talk about the speed. So you'll talk about the magnitude of the velocity vector. That's about it. So let's see if we can do this. So a particle moves with position e to the t cosine of t, e to the t sine of t. That looks really unhappy to me because, so what is that? So cosine and sine give you a circle, but then e to the t is making the radius like increase. So I think this is like a spiral. You could check that out on the calculator. Also, the problem mentions if your calculator skills are weak, I actually have already done this problem in another video using the calculator all the way through. So I think if you search for that, I don't know, or if you search my YouTube channel for that, you will definitely get that video. So I'm going to try to solve this by hand. Find the particle's velocity vector at time t equals 1. All right, so I need to find v of t. So v of t is going to be r prime of t, which is going to be like just so much product rule. So it's first derivative of the second plus second derivative of the first, and then it's first derivative of the second. That's not the derivative of the second though. Derivative of the second, and then plus second derivative of the first. Okay. I feel like I should simplify this because, well, I just need the velocity vector. At this time, is its x-coordinate increasing or decreasing? How fast is the particle going? All right, so this is annoying. So v of t is how fast. I'm going to have to find the speed. That's unpleasant. So e to the t, then cosine minus sine, comma e to the t, cosine plus sine. Oop, parentheses. Okay, so v of 1. That's a bad arrow, man. V of 1 is e, and then cosine of 1 minus sine of 1, which is like whatever, comma e cosine of 1 plus sine of 1. And like, sure, that's true. That's what it is. But like, what does that represent? This of 1 thing looks just horrible. Okay. So that's it. I don't know. Is its x coordinate increasing or decreasing? So I need to figure out if e times cosine of 1 minus sine of 1 is greater than or less than 0. So what I'm going to do is, not like a lot of space here, but I'm going to pick up this stuff and just move it to the side so I have a little more room. And then, okay, so what I really need to do is just figure out if cosine of 1 is bigger than sine of 1. And I think we can do that graphically. So what do I need? I'm going to try to put cosine and sine on the same set of axes. I need like a semi-accurate graph here. So 2 pi, boom, boom. Okay, so let's do, here's 1. Let's do sine first. We'll do sine in blue. Here, here, here. And then that's all I'm actually going to need. So this is sine. Sine of t. And then I'm going to do, I don't know, different color here. Cosine. It's like, this is actually all I'm going to need. Why do I think that's all I'm going to need? Because pi over 2 is 1.57. So this happens, but then pi over 4 is like 0.78. So it's somewhere between pi over 4 and pi over 2. Here's pi over 4. Here's pi over 2. It's probably like a super easy way to do this. I mean, 1 is like almost 60 degrees, and you could just like go with like the cosine of, like 1 radian is almost 60 degrees. So pi over 3, like the cosine of pi over 3 is 1/2, and the sine is radical 3/2. And so it's definitely negative. I mean, so that's telling me that the sine is above the cosine. You can see like on that interval, this is some deep work here. On this interval, basically, cosine is below sine. Sine is bigger than cosine, which means that overall, so I'm going to say at t equals 1, e times cosine of 1 minus sine of 1. So since sine of 1 is bigger, is less than 0. Therefore, x coordinate is decreasing. Okay, I think we got that. You had to do a little analysis of the graph there, though. So that's the thought process. How fast is it going? I need the magnitude of this thing. So, all right. So square root. I need the magnitude of v of 1 is, so I'm gonna end up with like just an enormous radical. So I'll put the like thing across at the end. I need to square this. So that's going to definitely give me an e squared, and then it's going to be cosine squared minus 2 sine cosine plus sine squared. Cosine squared minus, so e squared. Nope. I mean, like, why are we auto whatevering? I get cosine squared minus 2 sine cosine. I'm never going to fit this. And then plus sine squared of 1. Why did I ever think that would fit? So I don't know what the proper way to break this is. I'm going to put like plus, and then it's still like going to be under there. And then there'll be another e squared. And then you just get cosine squared plus 2 sine cosine. So cosine plus 2 sine cosine. There's no way that there's enough room to do this problem. So this, so we get that. So holy cow, no room. All right, so I'm just gonna keep going here. Like, should I just insert a new page? I mean, I should have done that. Should have done that ages ago, I hear myself saying. Add a page, and then I gotta like copy and bring some stuff with me. Bring this with me and simplify it. Don't worry, I guess I'll duplicate it and bring it with me. We got this, maybe. Okay, so now we got plenty of room to play. Let's move this up and make it like a thing. Okay, maybe. There. Looks almost like I did it intentionally. All right, so what do we have? We have the square root of, no, we have the square root. And then there's an e squared. And then this, so e squared you can take out of like both of them. And then you have cosine squared plus sine squared is actually 1 minus 2 sine cosine. And then you actually get another 1, right? Because of another cosine squared and sine squared. So that's going to be plus 1. And then there's plus 2 sine cosine. And so what do I get? I get 1 plus 1 is 2. So I get the square root of 2e squared, which is radical 2 times e. I think that's your speed at 1. I don't know. Check out the calculator video and see if that's accurate. How far did the particle travel between 0 and 1? How far is the particle from the origin at that time? Oh, this is terrible. All right. So, I mean, I already know that I'm not going to have enough space, but let's try it out. So I got to find the magnitude of this, which is like almost the exact same process that we just went through. Like, I think it's just going to end up, so we have to do the integral from 0 to 1 of the magnitude of v of t dt. I want to skip like every step, but I don't think I should. Like, I don't think educationally that's a good idea, but I mean, I think that it's a good idea. We're gonna end up with an e to the 2t. I'm just gonna like factor as I go. So, I mean, you're gonna get, so what are you gonna get here? You're gonna get this squared, and then minus 2 sine cosine, and then plus sine squared. So that's going to give you sine squared plus cosine squared is 1. So you're going to get, again, 1 minus 2 sine cosine. And then when we deal with this, we're going to get cosine squared plus 2 sine cosine plus sine squared. Sine squared plus cosine squared is another 1, and then plus 2 sine cosine. And if you don't like this, you know, go back and show a lot of work. That's totally up to you. So this is 0 to 1. We end up with the same thing again. So it's like e root 2 and then t dt. Where's t come from? There's no t. E to the t. I got it. Hold on. So it's the square root of e to the 2t is e to the t. E to the t root 2 dt. So that's going to be e to the t root 2 from 0 to 1. Remember, when you plug in 0, it doesn't like zero everything out, which is like one of those things that everybody wants to happen all the time. It's going to be root 2 and then e to the first minus e to the 0. I believe this is the distance traveled. So I'm going to highlight that. This is the distance traveled. So distance traveled. Now, how far are you from the origin at t equals 1? We need to find r of 1. So r of 1, if we just plug in to something, is going to be e to the first cosine of 1, e to the first sine of 1. So e to the first cosine of 1, e to the first sine of 1. So that's your position. So then your distance from the origin is the magnitude of that vector. So distance from the origin. It's not even your displacement because you haven't moved yet. Oh wait, no, that's your is that your displacement? No, because you don't know. What is the question? How far is it from the origin? Not how far is it from where it started. So from the origin, I don't really know how to interpret. I mean, it's just the distance to 0, 0. So it's going to be the square root of is the magnitude of r of 1. Am I doing a good job on these problems? I don't know. I never know. So it's e squared cosine squared plus e squared sine squared, which is just like the square root of e squared, so it's e. So this is your other answer. This is your distance from the origin. I don't know why you would think those are the same, but like if you did, they're not. All right. Then one last question, acceleration vector. I have to find the derivative of velocity. That doesn't seem pleasant. Okay, so is there a shortcut on this one? It's not looking like it. I'm going to copy my velocity vector just so I can differentiate it more easily. And then this is, you don't have to watch this if you don't want to. This is just Calc 1 gone crazy. All right, so a of t. Am I going to fit this? No way. All right, first derivative of the second is negative sine of t minus cosine of t. Plus second derivative of the first. That's just like the normal. Like, is something magical going to happen here? Is there like something magical that I should recognize that I'm not recognizing? Possibly. First derivative of the second. Plus second derivative of the first, which is just it again. Then I got to put in, what's the magnitude of acceleration? Somebody answer me that. Like, what does that represent? Okay, a of 1. Whew. E, and then like, I don't know. So you're gonna get E, you have minus sine of 1, minus cosine of 1, plus cosine of 1. So those are gone, minus sine of 1. So it's like minus 2 sine of 1. And they don't even like play together, so it's not like something can cancel. So we're just going to get E, and then you have minus sine plus cosine plus cosine plus sine. So you just get 2 of the cosines. And there you have it. Like, what is the point of doing this problem by hand? I don't think there is one. I don't know. I think that's your acceleration, though. I'm not 100% sure. Also, I'm not going to check it because there is the other video. So hopefully you'll go find that video and watch it if you want to see if I got it right or not. And I'm going to end this video. Who knows how long this is? I feel like it's like 200 years, but maybe not. So I will see you in the next one.